Bismillahirrahmanirrahim. Dear students, our chapter of protection of hydroxyl group has been continued. So the last two examples of ethers as protecting group we will study today, that is MEM, that is ethoxymethyl ether, and SEM, that is trimethylsilyl ethoxymethyl ether. Course, you already know role of protecting group in organic synthesis, and my name is Dr. Tahir Makbul. So let's come on to the objectives. Here we will discuss installation, characteristics, removal, and finally the application of these two groups, that is ethoxymethyl and trimethylsilyl ethoxymethyl protecting groups, which were being used for the protection of hydroxyl group or alcohols. So firstly, the 2-methoxymethyl ether, that is O-MEM group. The general formula is OCH2, OCH2, CH2, OMe. So here are some features. MEM ethers, as you know, we have discussed the MEM methoxymethyl ether. It is quite similar to the MEM. MEM is quite similar to MEM and SEM, which we will discuss here today. In which way these are stable? In the way their stability to protic acid, because these are stable to protic acid, but these are more sensitive to lewis acids. Reason is pretty obvious that what is the difference between MEM and MOM? There is only one methoxy group, that is methoxymethyl ether. Here there is ethoxymethyl ether. So the additional ether group basically improves the ability to coordinate with the lewis acids more strongly than MOM or SEM. So another oxygen, you mean to say, which have a lone pair, has additional ability to coordinate with the lewis acid. That is why it is more sensitive to lewis acids. Among the other features of this 2-methoxymethyl ethers are, it is stable between pH 1 to 12, which is a broad range. So you need very strong acid in order to cleave this group. It is also stable to oxidizing agents, hydrogenation. It means by protecting the alcohol with MEM, you can carry out the hydrogenation. By protecting the alcohol with MEM, you can carry out the reaction with nucleophiles, you can carry out the reaction with hydrides. These are also stable to organometallic reagents. However, these are sensitive to strong aqueous acid. The pH should be less than 1, because generally it has been found that it is stable in the range of 1 to 12. So you need to have a strong aqueous acid in order to react with O-MEM group. Similarly, as we have already discussed, it is also stable to lewis acid, reason being the additional ethoxy group which can coordinate with the lewis acids. Here is the most common method for the installation of 2-methoxymethyl ether, that is O-MEM group. We have treated alcohol with ethoxymethyl chloride, that is MEM chloride. DCM was used as a solvent, and diisopropylethylamine has also been employed in order to get the protected alcohol. Here is the most common method for the removal, or general method, you can say. The RO-MEM group MEM substrate will be treated with zinc bromide or titanium chloride in DCM in order to regenerate your alcohol. As far as applications are concerned, I have drawn one application which has been taken from the core synthesis of gibberellic acid. You know about the gibberellic acid. It is a hormone which is being obtained from the plants. Core used this O-MEM protecting group in order to protect this tertiary group, that is tertiary hydroxyl group, tertiary alcohol. He treated the compound 51 with our MEM chloride in DCM, in the presence of Unix base, that is ethyl diisopropylamine, in order to get the production of this hydroxyl group with MEM group. Elaboration of this 52 have given the 53 compounds. The final step is the deep protection, in which zinc bromide in chloroform, ether, acetonitrile. These reagents has been applied in order to remove this O-MEM group and get the alcohol back, that is compound 54. So for further application, you may visit the page number 49 of Green's Protective Group in Organic Synthesis. I can show you the book here, page number 49 here. That is the 2-methoxymethyl ethyl or MEM OR group. काफ़ी सारे मेथड दिए गए हैं. You can see that they are used sodium hydride or potassium hydride, MEM chloride, THF or DME, 0 degree Celsius in 95% yield. In the second method, they have got 90% yield. Similarly, in the third method, so these all the three reagents have been applied for the formation in only single paper. So you can get this paper and get all the three methods in details and their examples. As far as the fourth one is concerned, अगर आप थोड़ा सा गौर करें, this alcohol is sterically similar. Sterically similar mean this OH is in the vicinities of this you can say sulfide group and ester group and hydroxyl. अगर आप इस OH को देखें, ये इसकी सेकंड पोजीशन पे है, ये थर्ड और फोर्थ पे है. अगर आप इसको देख लें तो ये इसके सेकंड पोजीशन पे है और दिस वन इज एट थर्ड एंड फोर्थ. सो दीज आर स्टेरिकली सिमिलर. इलेक्ट्रॉनिकली डिफरेंट कैसे हैं? ड्यू टू दिस डबल बॉन्ड एंड these groups, बिकॉज यहाँ पे तीसरी पोजीशन पे सल्फाइड है, यहाँ पे तीसरी पोजीशन पे आपका कार्बोक्सिलेट ग्रुप है. सो इलेक्ट्रॉनिकली these two hydroxyl groups are different. So when they have treated with MEM chloride in chloroform and DIPEA at 0 degree centigrade, so a mixture of MEM protected alcohol have been obtained. The major product is 49%, in which this hydroxyl group is protected, while the minor one is 19%, where this hydroxyl group is protected. Similarly, here are some methods for its cleavage. In the first method, zinc bromide we have also mentioned in gibberellic acid synthesis. So there are other reagents which has been applied for its cleavage. So you can get these references down here. And get these respective papers and the examples in detail. So I move on to the next group, that is O-SAM group. O-SAM trimethyl ethoxymethyl ether. Its general formula is OCH2 OCH2CH2 trimethyl silane. As far as key features are concerned, the first one, it is developed by the Lipschutz, which is the name of the scientist who developed it. Basically, TMS group is used as a trigger for the facile deproduction of alcohol. It is stable in the range of 4 to 12. So you can say that the stability as far as in comparison with O-MEM group is quite less towards the acid. It is also stable to oxidizing agent, hydrides, organometallic reagents. However, it is sensitive to some nucleophile, many Lewis acids, many fluorides. So tetrabutyl ammonium fluoride usually being used for its regeneration. SAM ethers are also stable to acidic conditions. those acidic conditions which were used to cleave the tetrahydropyranyl and tertiabutyl dimethyl silyl ether. We have discussed both these protecting group during our lectures in the class, so I will not go into the further details. Overall, this is very robust. Robust means it is very strong protective group that is often difficult to remove. However, it still have its application in the literature. The method of installation, we have only replaced the methyl with the trimethyl silyl group, and Unix base as usual has been applied. So we treat the alcohol with this chloromethoxy trimethyl silyl ether, and we get the protected alcohol. As far as removal is concerned, you can use tetrabutyl ammonium fluoride and hexamethyl phosphoramide in order to regenerate the alcohol. Application, the OSAM group has its application in backward synthesis of negative australide B. Here you can see that the alcohol unit in 55, that is the secondary alcohol, has been protected by using the OSAM group. Secondary alcohol unit in 55 was protected, converted into OSAM derivative by using the reagent and Unix base. Synthetic manipulation over 9 step gives this 57, which is not our headache. However, the final step is the deprotection of this OSAM group by utilizing the tetrabutyl ammonium fluoride in the presence of hexamethyl phosphoramide at 45 degrees centigrade. It has yielded the unprotected hydroxyl group again. So further application, you can go into page number 54 in Green's protective groups in organic synthesis. I can show you the page. Here is the 54. ये जनाब 2 trimethyl silyl ethoxymethyl ether or SEM ether, you can say. Here are the method of its formation. पहला मेथड देखें तो सेम रीजेंट है, यूनिक्स बेस है, डाइक्लोरोमीथेन 35 to 40 degree Celsius है, 1 to 5 hours है, 86 to 100% yield है. That is the reference number 2. Similarly, here they have used 2,6-ditertiary-butyl-pyridine. The reagent is same, and they have got 56% yield. There are some other methods. क्लीवेज के मेथड्स भी इसी तरह हैं. एग्जाम्पल्स भी हैं. सो आप किसी भी रेफरेंस का पेपर यू कैन डाउनलोड, गेट द कंप्लीट पेपर टू सी द एग्जाम्पल. So here is another table, that is relative cleavage rate for selected ethers of primary alcohol. There are different ethers. You can also get some practical knowledge for if you are working on a synthetic project. So here are the references. So यहाँ तक जो हमारे एसिटॉल्स एंड ईथर्स एज अ प्रोटेक्टिंग ग्रुप ऑफ अल्कोहल का चैप्टर है वो ख़त्म होता है. इससे पहले मैंने 2 लेक्चर ऑलरेडी अपलोड कर दिए हैं, जिनके अंदर हमने डिस्कस किया था एसीटेट और बेंजोएट्स को. सो नेक्स्ट कमिंग लेक्चर में इंशाल्लाह हम नेक्स्ट क्लास या नेक्स्ट चैप्टर के ऊपर उनके प्रोटेक्टिंग ग्रुप के ऊपर बात करेंगे. तब तक के लिए अल्लाह हाफिज़, फ़ी अमान अल्लाह.